Alright, so let us continue with some example that involve the calculation for the type 1 and type 2 error. Okay, so let's have a look for example 29. Alright, okay, so when we read the question, okay, so again, the first keyword will be the normal distribution from here. And then you know that the time spent at cash withdrawal point, the mean is 2.1 minutes, and also the standard deviation is 0.9 minutes. Right, so a new system is tried out to speed up the procedure. So the null hypothesis is the mean time spent is the same. Then here they already tell you the null hypothesis now. So it is decided to reject the null hypothesis and accept that the new system is quicker if the mean withdrawal time from a random sample of 20 cash withdrawals is less than 1.7 minutes. Okay, so here they said reject the null hypothesis, okay, and accept that the new system is quicker if the mean withdrawal time from a random sample of 20 cash withdrawal is less than 1.7. Right. Then after that, assume that for the new system, the standard deviation is still 0.9 minutes and the time spent follows a normal distribution. So first one, they want you to calculate the probability of a type 1 error. Okay, so if you look at this example, right, they want you to calculate the probability for type 1 error. So if you read through this whole question, you didn't see the alpha given. They didn't give you any alpha at the significance level. Therefore, you have to calculate the type 1 error on your own. All right, so there's no other choice. You have to calculate the type 1 error on your own. Okay, so first of all, usually when you want to calculate the type 1 and type 2 error, right, I will prefer students to write out the null and alternative hypothesis first. All right, so what is the null hypothesis in this case? So you have the mu, which is equals to 2.1 minutes. And then for the alternative hypothesis, because of they want to test whether the new system is faster, right? Is quicker. So that means they want to have mu smaller than 2.1 minutes. All right, so this is your null and alternative hypothesis. Okay, then now let's start. When they want you to calculate the type 1 error, all right, so the definition for type 1 error will be reject the null hypothesis when the null hypothesis is true. All right, so for this part, the reject null hypothesis, you need to find out the rejection region. Okay, so where can you get the rejection region? Maybe you can read the question another time. Okay, so read these two sentences another time. All right, so here they say it is decided to reject the null hypothesis. So this one means that reject the null hypothesis, okay, and accept the new system. Okay, when the mean withdrawal time for a sample. So mean withdrawal time means sample mean less than 1.7 minutes. So less than 1.7. Okay, so from this sentence, you know that you can write out sample mean smaller than 1.7. And what will happen if sample mean smaller than 1.7? So they said we will reject the null hypothesis. So that means you will reject null hypothesis when the sample mean is smaller than 1.7, which means also this is actually your rejection region. You reject the null hypothesis under the rejection region, right? Okay, when we draw the diagram in the previous part, when we try to learn how to carry out the test, right? So you have to remember that reject the null hypothesis, which also means that it belongs to it refers to the rejection region because you reject the null hypothesis when your test statistics or everything is under the rejection region. All right, so that means from this sentence, okay, when you try to analyze it, this is actually the rejection region that they give you. So this is rejection region. All right, so if I want to put it in my calculation, then it will be something like this. Okay, so sample mean smaller than 1.7. Okay, then they say null hypothesis is true If null hypothesis is true, that means that this is true. So if this is true, means what? Your mu is equals to 2.1. Okay? Alright, so this is how we write out the symbol here. And after that, how to continue? Okay, so because this is a normal distribution, right? So you have to change your sample mean become Z. You have to standardize it. So to standardize it, it is sample mean minus the population mean divided by standard deviation. So the standard deviation is 0.9 over square root n. So what is the sample size that you are using in this test? So it should be 20. Alright, so you see here, 20 cash withdrawal. Alright, so this is what you should have. Okay, so can you see that although this is the conditional probability symbol, but when you do the calculation, right, you actually didn't divide or anything else. You just apply the normal type of calculation only. Alright, so change the sample mean become Z. And then after that, I think the rest of the steps will be quite easy for you already. So you have smaller than negative 1.988. Then you will have 1 minus 0.9766. And eventually the final answer for the type 1 error will be 0.0234. So this is how we calculate the type 1 error when they give you a rejection region. Alright, so in my opinion, right, this is very important because you need to know how to get this rejection region straight away from the question first. So this question actually is quite simple because they straight away give you this as a rejection region already, but you need to identify yourself lah. Alright, so from this sentence, you know that sample mean smaller than 1.7 is actually the rejection region because when sample mean smaller than 1.7, right, you reject the null hypothesis. Okay. Then what is this formula here? So all this formula here is actually the test statistic formula. Z is equals to sample mean minus the mu divided by standard deviation over square root n. So this is a test statistics formula. Alright. So this is what we have for type 1 error. Okay, then now maybe you can proceed to part number 2 for this question. Alright, so if you have a look for part number 2, here they said if mean withdrawal time under the new system is actually 1.5 minutes, calculate the probability of a type 2 error. So for part number 2, very obvious, they want you to calculate the type 2 error now. Alright, so type 2 error means what? Means that you accept the null hypothesis when the null hypothesis is false. So all the definition here, you need to remember yourself. The type 1 error and type 2 error definition, you have to always remember it. Because if you didn't remember, then generally you don't know the definition, then you cannot continue with the calculation. Alright. Okay, so let's start. Type 2 error, they want you to have accept null hypothesis. So accept null hypothesis means that you need to put in acceptance region. Like just now, you already know that sample mean smaller than 1.7 is rejection region. So acceptance region will be the opposite meaning. Correct or not? The opposite sign. That means the sample mean greater equals to 1.7. This one will be your acceptance region. So once you get the rejection region already, automatically you will know what is the acceptance region as well, which is the opposite sign only lah. Alright, okay, so this is the acceptance region. Then they said null hypothesis is false. So that means this is false. Mu is not equals to 2.1. If mu is not equals to 2.1, so what is the value that you can use to calculate your probability? Therefore, you will see this one always. In the question itself, when they want you to calculate the type 2 error, right, they will also give you a new value for the mu. Because when mu is false, is not wrong, they will give you a correct value here, which is mu equals to 1.5. So far, any problem or not? I hope that you can understand the idea here lah. Alright, Then again, after you write out everything here, then you can continue with the calculation. Same step. Z greater than, you have to standardize it. Yeah, standardize it. So 1.7 minus 2.1 divided by 0.9. Oh, sorry, I make a mistake here. I shouldn't put 2.1 here. I should put in this new value, which is 1.5. Okay, so you have to use the new value of mu given in the question. Then you will have z greater than 0.994. Okay, then you continue with the calculation by finding out the value from the table, and you will get 0.1601. Alright, so this is the value that we have as type 2 error probability, and this is the type 1 error probability. So in general, when you want to calculate the type 1 and type 2 error, right, you need to have the rejection region and acceptance region. Okay, then of course you need to have the mu value, the mu value when the null hypothesis is true, and also the mu value when the null hypothesis is false. So this value itself, null hypothesis is false one, the mu value they will give you in the question usually before the calculation. Right, then when you continue with the calculation part, the steps are quite standard. That means you follow the normal distribution calculation. Then you can get the probability very easily. Alright, okay, so this example also, there's one point here where the question itself gives you the rejection region in the sentence. So this actually makes your process easier. Okay, because the rejection region is already given in the question. Alright. Okay, so if let's say you have the idea on this, then maybe you can try the next example 30. Okay, so for example 30, if you have a look for the question itself here. Okay, so first of all, you see the word normal distribution. Okay, and then you have mu and also the standard deviation 3. Okay, so here they straight away tell you the null hypothesis is mu equals to 20, alternative hypothesis is mu greater than 20, the sample size is 25. It is decided that the null hypothesis will be rejected if the sample mean is greater than 21.4. Okay, so I want you to focus on this sentence again. They said decided that we will reject the null hypothesis. So this one means that reject null hypothesis. Okay, if the sample mean is greater than 21.4. So that means this one, sample mean greater than 21.4. So what does it mean here? So this means that it is actually the rejection region. Because you reject the null hypothesis under this condition, right? So that means this is actually the rejection region. Okay, so again, very similar to what we discussed just now in example 29. So I want you to try this example on your own. All right, so I will give you the final answer here first. Then again, later I will upload the PDF version of this answer in Blackboard later. Right, so for the final answer of type 1 error will be 0.0098. And after that, for the type 2 error will be 0.7477. Okay, so I hope that you can try it out first. Then check the answer later. Alright, okay. So example 29 and example 30 are both examples that the question itself already give you the rejection region. Alright, then now let us continue further for example 31. Okay, when you read through the question, you see the keyword normal distribution. Mu, you don't know yet. Variance is 12.8. So a test at 5% significance level, the null hypothesis is this, alternative hypothesis is this. Okay, at a random sample of 20 observation of X. Okay, so first question here, they want you to find out the rejection region. So it's very clear. They want you to find out the rejection region of the test in terms of sample mean. Okay, so how to find out the rejection region of the test? Okay, so usually this is the part that is slightly more complicated, but to me, as long as you are very clear with the basic concept on hypothesis test, then generally it won't be a very big problem for you. Okay, so I will write out this again. This is 5, then mu greater than 5. Okay, so now usually when I want to find the rejection region, I will use the graph again. This is a normal curve, right? Normal distribution, therefore I will draw a curve again. And then according to the null and alternative hypothesis, I know that the rejection region is here. Okay, so this area is 0.05. And then you know that this is your critical value, right? So critical value. What is critical value? So you have to find out the critical value from the table. So if you find the critical value, you realize that it is 1.645. Okay, so according to the diagram that we draw, this is what we have as the rejection region. Okay, so now according to this diagram, if I want to find out the rejection region, right, you know that the rejection region is when Z more than 1.645. Because you know that when your test statistic is more than 1.645, then you reject the null hypothesis. So you know when Z is more than 1.645, then you reject. Okay, so what is Z here? What is the test statistic formula in normal distribution? So just like I told you, right? Z is actually sample mean minus the population mean divided by standard deviation over square root n. So when it is more than 1.645, then you reject the null hypothesis. Okay, so I substitute all the value in. Sample mean is 5. Then variance is 12.8. N is 20. More than 1.645. And eventually you will get more, the sample mean x is greater than 6.316. If you want, you can change it become 6.32, but for me, I will just keep it here. Okay, so you can change it become 6.32. So this is the rejection region of the text. All right. Okay, so you actually get it from the idea on the graph. So you know that when the test statistic is more than 1.645, okay, then you reject the null hypothesis. You substitute it with the formula for the test statistic, then slowly move everything over, then you get sample mean more than 6.316, then you reject. So this is your rejection region. Right, so this is how we actually get the rejection region from the concept that we learned before. Right, so in exam, if you don't want to sketch this graph out, it's okay, because I sketch it here to let you visualize it and to understand it better. Okay, but if let's say in your mind you already have this graph, then you can straight away write all the steps like this if you understand. All right, so this graph will not give you extra marks. All right, okay, so this is how we get the rejection region. Done already. Then after that, you need to find the probability of a type 2 error when the value is 7. Okay, so now part number 2. We want to calculate the type 2 error. Right, so what's the type 2 error definition? You accept the null hypothesis when the null hypothesis is false. Okay, so when you accept null hypothesis means that you need to put in acceptance region. This is rejection region. Therefore, for acceptance region will be sample mean smaller equals to 6.316 with the opposite sign. Alright, so rejection is more than. Therefore, the acceptance region will be smaller equals to. Okay, then when the null hypothesis is false, that means they will give you a correct value of the mu, which is 7. Okay, so continue from here. I think it will be not a problem for you already lah. Okay, so sample mean minus the population mean divided by uh, variance 12.8 over 20. This is 20. It looks like 0, 0. 20. Okay, so from here, if you continue, you have z smaller equals to negative 0.855. And then you continue the calculation from this part to find out the normal distribution table. And eventually you should get 0.1963. Okay, so this is your type 2 error. Okay, so for this example, in general, right, you will see that a bit different from the previous example is in the previous example, they straight away give you rejection region. But for this example, they ask you to find out rejection region on your own first. So if you want to find the rejection region on your own, then generally you have to know the method. All right. So for me, usually I will use a diagram to guide me so that I can see very clearer. I can see very clear that when z more than 1.645, then I reject my null hypothesis. So from here, I can get the rejection region. Okay. All right. So let us continue to have a look for example 32. All right. So now, a boxes of dried, I think is haricot. Okay lah, haricot beans okay, haricot beans have contents whose mass are normally distributed. So again, you see the keyword normally distributed with the mean as the mu, and also the standard deviation is 15. So this is variance known. Okay, for population variance known. So null hypothesis is this one. Alternative hypothesis is this. All right, so 5% significance level using a random sample of 16 boxes. Okay, so this is a size n. All right, so let us have a look for part number 1. For what values of the sample mean is the alternative accepted? Alternative hypothesis accepted. Okay, so this one, what they actually want you to find out. When you write out, this means that you accept the alternative hypothesis, right? Which means that you reject the null hypothesis. Means that they are asking what value of sample mean is. So that means when will you accept the null hypothesis, or when will you reject the null hypothesis? Means that they want you to the rejection region, to get the rejection region. Okay, so you can see that this question is not straightforward. All right, but you have to understand the meaning. Okay, so for what values of the sample mean is to is the alternative hypothesis accepted. So alternative means you reject the null hypothesis, means that they want you to get the rejection region. Because you reject null hypothesis, right? So you want to get the rejection region. Okay, all right. So again, for part A, you are having the null hypothesis as mu equals to 375. Then alternative hypothesis is mu not equals to 375. Okay, then if you don't know how to start, then you draw a diagram to help you first. Okay, so this is a two-tailed test. I'm having a rejection region on the left. I also have a rejection region on the right. So now this should be 0.025 the area. Okay, this is also 0.025. Then by finding out the critical value on your own, what is the critical value here? Okay, so if you didn't do any careless mistake, the critical value will be 1.96 and also negative 1.96. All right. Okay, so now I want to find the rejection region. Okay, very obvious from the graph, you see two rejection region here. Therefore, for your final answer, you should have also two rejection region. One on the left, another one on the right. Okay, so for this one, you reject the null hypothesis when your test statistic is smaller than negative 1.96. And then when Z is more than 1.96, you reject the null hypothesis as well. Okay, so what is the formula for your test statistics? So X minus the population mean divided by sigma over square root n. Alright, so the same thing happened here lah. You complete it by yourself. Okay, eventually you will have the rejection region, which is X smaller than 367.65. Another one will be sample mean more than 382.35. And this is my rejection region. Okay, all right, so you please complete the missing part here lah. All right, I will want you to complete it on your own. And then for part number B, they want you to calculate the type 2 error, right? The value of mu is 330. Find the probability of making a type 2 error. Okay, so to get the probability for type 2 error, again, what is the definition? Accept the null hypothesis when the null hypothesis is false. And after that, for the acceptance of null hypothesis, you have this as rejection region, right? So the acceptance region will be here, which is between the two rejection region. So when you write out, it can be 367.35, okay, smaller equals to X. Then this one is 382.35. And given that the new mean is 380, all right, so continue from here. I want you to standardize the value yourself and try to get the probability. So the probability will be 0.7347. Okay, so please complete the missing part and see whether you can get the answer or not. All right, so this is how we actually try to find the rejection region. Okay, so from here, I hope that you can see a pattern. Example 29 and 30, you calculate the probability by having the rejection region in the question already. They already give you the value itself. Therefore, example 31 and 32, these two examples, right? Before you want to calculate the type 1 and type 2 error, you need to get the rejection region on your own first, yourself. Then only you can use the rejection region to continue with the calculation for type 2 error. All right. So this is what we have for the errors in normal distribution. So we ended the normal distribution part with the errors. So in the next video onwards, we are going to discuss the error in binomial and also Poisson.